All righty. Hello, I'm Jack Rickard with EVTV. This is my compadre and consigliere, El Breno Noto.
Hey, good to be here.
Why do they call you the Brain?
I must figure stuff out. I don't know. Or there was some cartoon a decade ago with two guys.
Pinky and the Brain?
Pinky and the Brain.
That's the real reason.
That's
and
the
I
real
tracked
reason.
it down. I'm going to show it right now.
All right.
Gee, Brain, what do you want to do tonight?
The same thing we do every night, Pinky. Try to take over the world.
The Pinky and the Brain, yes, Pinky and the Brain. One is a genius, the other's insane. They're laboratory mice, the genes have concise. They're Pinky and the Brain, 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 brain. Before each night is done, their plan will be unfurled by the dawning of the sun. They'll take over the world. They're Pinky and the Brain. Yes, Pinky and the Brain. Their twilight campaign is easy to explain. To prove their mousy work, they'll overthrow the earth. They're Pinky and the Brain. Brain, 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 brain.
The Pinky and the Brain, Pinky and the Brain.
What are we going to do tonight, Brain?
Well, I guess take over the world.
Try to take over the world. That's right. Steven Spielberg was actually the main producer on that. Sort of a little-known cult at the Acme Labs.
At the Acme Labs.
Two mice given brain enhancement. And in Brian's case, it worked, and in mine, being Pinky, apparently not.
Hey, you always come up with good stuff, though.
Yeah, it's September the 14th. It's Friday.
It is.
We've had a great week. I've had a number of losing days. You know,
We did have a few.
this is where you come in and you do something, and you go home and it didn't work.
No, over and over again.
Yeah,
serially.
And we've been struggling with that, but suddenly we've got it all going our direction.
Yeah.
The Cobra is running fabulously.
Yeah, it's running a lot better, and it's obviously a tribute to persistence. We just we kept coming back for more.
I had originally told Paul we'd do this in 3 months, and I thought, well, you know, with all that room and drop a Series DC in it, and
Yeah, just wham bam, thank you, ma'am. Yeah,
and it's not been that way.
No.
But we're getting there.
Yeah.
This thing is this has got more power than anything we've built.
Yeah, it's starting to feel really good now.
It feels good
Yeah.
to step on it.
Yeah, I know.
And I'm not, you know,
doesn't
I'm
even like
not
that
even going to, Brian's
He'll
gonna
come
have
over to the dark
do
side.
tire burning thing for you.
Oh,
the
yeah.
0 to 60. We'll go to Sling Blade next week to satisfy my technical curiosity.
Yeah, yeah.
But it scares me to do all that. Anyway, we had a little bit of a problem with this controller and the aux battery
Oh man.
being a solution. It was not a solution for me ever, and it went from bad to worse.
It was a nightmare.
And once we got it in there, we had all these loads that were draining the battery.
We had wires everywhere, contactors, boxes, switches, breakers.
And we ripped all that out and went
Yeah,
and
thank
found
God.
a different way.
Yeah.
Let's take a look. Last we met at the infamous whiteboard, I diagrammed how we were going to add an auxiliary battery, a lead acid battery, although of absorbed glass mat construction. Then I expressed my distaste for that. Well, we did it, and it was a mess, an absolute mess. Let me draw in a little LED light ring here. We've got a number of special needs. I call these parasitic loads. They're things that have to be on the car all the time. And if you want them to be otherwise, you can't. One of them that came up was David Kurzel's J1772 board. It's only about this size. Doesn't take a lot of 12 volts, but it has to have it in order to charge the car, to do the switching, to turn on the EVSE. It has to have 12 volts. The way I've got it rigged up is if it gets 12 volts and starts charging, it turns on a blue LED light ring. Now that's a pretty low draw as lights go, but for a parasitic load, it's pretty high, and it's on all night while our charger's hooked up. The Xantrex meter has to have 12 volts. That's how we're powering it, is we take our 12 volt DC, run it through a 12 volt DC to DC converter to isolate it so it can be used to measure our pack voltage and not spring a leak to our frame. We have another device called a Ziva 2, which again measures amp hours and runs our fuel gauge. We got a nice set of Speed Hut fuel gauges for Paul. It looks very Cobra, but I wanted the fuel gauge to work properly. And the Ziva also will let us display instantaneous current on our tachometer. Our speedometer has a GPS. If I don't have 12 volts on it all the time, it loses a satellite, and it's about a minute for this thing to acquire, which is annoying, so I want it to be on it. The net effect was, with all these loads and charging, I had a 7 amp hour battery, and then we went to a much larger 30 amp hour motorcycle battery, and we were eating them. And this is an ugly, stupid solution anyway, so we threw it out and went back to square one. Recall our original problem was the net gain controls was throwing 3 errors, 01, 09, and 14. Let's see if I can remember what those are. Oh, I don't need to remember, I've got them here somewhere. 01 is a throttle range error. Either the throttle unit is disconnected or has failed. I can confirm that the throttle is in there and working pretty good. 09, 15 volt power supply out of limits. Now, how could both those be true at the same time? The throttle runs on 5 volts. And 14, pack went open circuit with system on. The net gain also runs our contactor applying pack voltage to the net gain controls. And that was opening for some reason. I also got these errors when we switched off the ignition, which was kind of interesting. Ryan kept talking about noise, but noise should throw an error when it's operating or when you turn it on. I could turn on the net gain controls controller and clear the errors, and it would operate quite normally, and it would operate normally without errors. At the point where I switched the ignition to off, it threw these 3 errors, and the next time I turned it on, they would be there, and again, I would have to clear them in order to use it. So that was the problem. We've taken back out the aux battery. We're not going to do that. This was like every day I was adding another thing to the circuit to try to get all this to work, and we were chasing our tail. An auxiliary battery, a lead acid battery in a lithium battery powered car is a dumb idea from the get-go. It's just, but the problem is the battery is sitting there draining down. I could have put a bigger battery, get more days, but why are we doing this? I've got a 41 kilowatt pack. It'll run these things for about 6 months. And if I'm going to park the car for any length of time, I can simply switch the maintenance switch off, and we have no parasitic loads. However, the way I had it, I have to have 12 volts to even charge the car. And so the aux battery thing was, you get in this little circle where you need 12 volts to turn things on, and you want to tie things to switches that aren't on yet, to get the 12 volts. It doesn't work for me. So we cleaned it all out, and we're back to our original problem, 1, 9, 19, and 14. I decided this pump is a little motor. This XS Turbos is a little motor, and this Durali, or Dural, I'm not sure what the pronunciation is on it, has a fan, is a little motor. Those are inductive loads, and when you switch them off, the inductor will reverse polarity and try to continue to provide current. So I decided we had some bad voltage spikes, and that was what was throwing this off when we shut it off. I took a 600 volt diode and hooked it up to ground to my switch 12 volt bus. And I decided that that would shunt any reversed voltage spikes. It'd be a huge negative spike these would put out to ground. And I put that on there thinking I was very clever, and it had no effect on the function at all. So we started to disconnect things, and we found that if we, and again, sometimes you have to, had we done this one at a time, we would have found nothing and would still be lost. So we didn't disconnect them one at a time. We disconnected all of them. And then we hooked them back up one at a time. These weren't really together. They were on separate things, so I could pull them all off and put them back on. That way, we discovered that the XS Turbos fan or the Durali, either one, if we had all this disconnected, we had no errors out of our net gain controls. We could switch it off and it wouldn't throw an error. I hooked the Prius pump back up and we run it, and we turn it off and it didn't throw any errors. I hook up the XS Turbos and we run it and turn it off, and there's the arrows. Found the problem. Just kind of mechanically go through the motions when you do this sort of thing. We hooked up the Durali, ran the system, turned it off, and it also threw the error. So I've got two devices that are actually causing this error, and a big 600 volt 100 amp diode with very low forward resistance was not apparently shunting the spikes to ground adequately. This is kind of a mystery. What we did was disconnected the XS Turbos completely, and I put a diode directly in the line with the proper polarity to put 12 volts to the Durali and run it. But when we switched off the key, no positive spike could come back through. And believe it or not, that fixed the problem. We had conferred with Ryan Bohm at Net Gain Controls, and he was able to reproduce the problem because he has one of these Durali fans. We kind of worked together on just component selections for a good cooling system. And he now, at EV Source, offers this both ways. You can get kind of a minor cooling system based on essentially computer cooling components, clear tube and a little pump and so forth. Or you can get, and it's $700 or $800, but you can get basically my cooling system. With a Durali, a nice pump, actually a little better pump than I'm using, and a AN8 fittings, AN8 hose, that sort of thing. So this appeared to take care of the problem, but when he reproduced it, he found a funny, but should be obvious thing. But you know, I just never think this way. This is a motor with a fan on it. When you shut it off, you're no longer applying power, but it has a certain inertia and keeps spinning. That actually turns it into a generator, believe it or not. In fact, each of these was a generator, and when we would switch off the power to the switch 12 volts, we would actually cause these to start generating voltage, and we would keep, he said, 3 to as high as 5 volts on the input to the net gain controls. Now that's kind of interesting because when we have our 12 volts here, this was really switched. This comes from here. Our 12 volts comes from the Vicor, and we were hooked up to the Vicor. What happened was we would remove the 12 volts, but we still had 3 to 5 volts coming in on the input. This is a digital input. It'll take up to about, most of those that they're using now take up to about 18 volts. But really, they sort of have their logic is still about 2.4 to 2.8 volts. Anything above that is read as a 1, and anything below that is read as a 0. And so what would happen was we would disconnect our 12 volts from the controller, but we still had 3 to 5 volts. When we went to off, we disconnected the 12 volts from the controller. It was actually not connected here, but connected here. And so when we turn the switch off, we lose our 12 volt input, but we kept a 3 to 5 volt here. What net gain controls read that as is that while we're on, a couple of things happen. One is our 15 volts is no good. Well, the 15 volts is made from the 12 volts with a DC to DC converter internal to the controller. Our throttle is no good because the 5 volts is made from the 12 volt input, and we're still reading that we're on, but we've lost the input from the throttle indicating an open. And so we've got a throttle fault. And because we removed the 12 volts, we've disconnected the contactor and removed the pack. That's our 14 that we've somehow lost pack voltage. And all this is because of this digital 1 on the caused by our fan acting as a generator. I've talked to Ryan about this. This is not acceptable. He has to fix this in the device. You can't have, people have to have special provisions with diodes and such for the for having fans off a switch 12 volt. Your 12 volt system is going to have headlights, turn signals, horns, motors, pumps, fans, and all manner of things on it. And he has to be able to operate this controller. They call it the industrial. I'm growing fond of it, actually. This sounds like a complaint, but it's pretty strong. So he's got a little problem there. Our workaround is pretty simple. We took a relay, just an ordinary Bosch 30 amp relay, disconnected from that line entirely, brought it over to the relay, and tied the relay over directly to our Vicor DC to DC converter. And so with it closed, we get the fans running. With it open, we don't. And we put the relay on our on situation. Now, when we turn it off, we do remove the 12 volts from here, and we disconnect this, turning off our fans, but as they turn into generators, the 3 to 5 volts is only felt down here, and we no longer have that up here. It's not on our switch 12 volt bus at all. In fact, the fans are never on our switch 12-volt bus. They're connected directly from the Vicor DC to DC converter through this relay, which is it's one of the little $4 Bosch 30 amp relays on eBay that just run on 12-volt DC. So we use our switch 12 to close the relay and connect the fans directly to the output of the converter. When we disconnect it, the 3 to 5 volts still made by the inertia of these fans, but they can't get past the relay, and they're not on our switch 12-volt bus and not on his digital input as the 3 to 5 volts he was seeing before. Without the on, the net gain controls industrial, warp drive industrial, doesn't think it's on. It goes into shutdown and doesn't expect 12 volts, 15 volts, 5 volts, or anything else. It knows it's off. And so that was the workaround solution. I've encouraged Ryan to pursue something in hardware or software to where you don't have to deal with this so much. But it does come up. But I wanted to share with you kind of the troubleshooting route that he found this generator effect. About the time I found the diode would keep us from throwing the error. And this is simply a workaround solution that's pretty simple for us right now. I can imagine when this thing arrives in Taiwan and Paul's going through the car and he finds this relay with 4 or 5 wires that doesn't appear to do anything useful. And he's gonna pull all these wires and just hook this up to the switch 12 volt, and then the car won't work. And so that's the kind of oddity you get into. But I thought I'd share the process. And again, building these cars is an exercise in small problem solving. And in this case, and we knew it going in, the net gain controls warp drive industrial is he classifies it as a beta product. I thought it'd be a neat controller to try, a new device to show you all. And 1400 amps is the highest available power to me that would be available to you. The Shiva wasn't announced yet. The Zilla wasn't available at the time I made that decision. And so I thought this would be a nice, neat new thing. And I kind of beat him up to give us one when he was really still working on the engineering on it. Anyway, that gives him some feedback. We're giving him temperatures and so forth and what we're seeing. Next week, we will go to Sling Blade over in Illinois and put this car on the dynamometer, and I expect to have some more information there. So in this case, it's not really a product claim, any of it that they're advertising. We're kind of working with them on a new device that I think will be very promising in a lot of ways. I like the package that it comes in, and so far the configuration and everything, you know, I'd like to be able to map the accelerator myself, but for most people that's a little strange actually. And he's got a very easy configuration. There's just a couple of things to set, an easy hookup, a very clean hookup, and so it's a good mate for that 11 HV motor. Next week we'll see what it really does. Stay with us. This episode of EVTV is brought to you by the Winston Battery Company Limited, makers of high-capacity lithium, yttrium, rare earth cells, including the popular 160 amp-hour model featuring cycle lives in excess of 5,000 cycles when discharged to 70%, the longest useful working life of any available battery of any chemistry. A leading battery technology scientist, inventor, and entrepreneur since 1995, Mr. Winston Chung envisions a new world of clean electric power for the dawn of a new era of electric vehicles. For your next electric vehicle design project, contact Winston Battery Limited. Energy for a bright future. So that's how we got
a lot better.
Got things
Yeah, thank
working
God.
back a little bit.
And we just got that working last night, Thursday night. So yeah, we spent some time on that.
We're going to do this backwards this week and show our good stuff, and then talk about the news and lighter things.
All right.
We took the thing out for a drive. I hope that turns out on our new Contour
the cam.
HD Plus
Yeah.
cam, and got about, again, 2 miles per 2 amp hours
2
per
amp
mile.
hours per mile. You still have that issue.
180 amp thing, that's a 90 mile max, maybe a 80 mile car. And that's actually less than we're accustomed to doing.
Yeah, yeah.
But you took it over to the alignment shop today. What did they have to say?
Well, we got half of the alignment done. We got the rear done. It was going down the street kind of sideways like this. The tires were canted toward the curb. It has a some kind of multi-link suspension, kind of like on a Chevy. Triangulated links or something like on a GM A body car. So it's quite a bit of work. It's not a pan-hard bar, and the way it's set up, they actually have to take them off to change to roll the heim joints in and out instead of having two, opposite left and right where you can just loosen them up. So Brian's got I'm sure it's a less expensive solution, but it's a little more difficult to deal with. The front end we still have to do. We have an 11-inch, 5/8 by 11-inch bolt that goes through two heims for the upper A-arms, and the nut isn't one of those nylocks. It actually kind of clamps on with metal, the nut to lock. It's seized onto the threads. So he's sending us a couple of those, and we'll be able to do the front end. So right now, the rear end is looking good. We got the car set to where it's kind of sitting square, but we don't know what the front end is like.
We don't know which direction.
We don't know which end the front end is going exactly. So there may be something there, Jack.
It's rolling pretty well. It's a heavy vehicle. We're going to weigh it next week.
Yeah.
But it's certainly 3,000 pounds.
Yeah.
And probably over.
Probably over that, yeah.
And yeah, with that Charger, it's over.
Yeah. Yeah.
And, just this, did I tell them we're going on a drive yet?
Yeah.
Did we come back?
No, we're still here.
Okay.
I guess we should go on a drive.
Let's go to the drive.
All right, let's go on a drive.
All righty. First thing we're going to go try is the soapbox derby test. Just like the Spider and the Speedster. Let's see how far we roll down the hill. In neutral. We've been having some interesting results with this car. Actually, not very interesting. About 2.5 amp hours per mile at 230 volts is over 435 watt hours per mile. That was horrible. But as we drive the car, we got that down to 192 and then 175 and 1.75 amp hours per mile. And I think we've just got an issue with new components that are not doing very well. Now I can tell you, we're already way past the Spider and kind of coming up on Speedster territory here on the Soapbox Derby. We're right next to Monk's, and so that's not too bad. We are reset to do this test, and let's go do a lap around the thing using our Xantrax and our GPS speedometer to measure the amp hours. Now, we had it aligned this morning and they were unable to complete it. As it turns out, the alignment on this vehicle is quite a complex process, and they were able to do the rear end, which they said was basically aimed off into the curb badly, and so we should have an improvement from our 1.75. We will see. Still kind of got howling brakes, but again, these are new pads, new gears, new differential, and it just seems like they're not all worn in yet. And so our results are kind of suspect. I'm going to pull up here, put it in first gear. So we did take it to Clark Alignment. He's got a couple of race cars. The guy knows what he's doing. He said the Cobra is really pretty complicated alignment, a lot of adjustments. Has a tri-connect or triangulated positioning on the rear end, and there's a couple of bolts on the front end, one of which is seized already, and we've ordered a replacement. They'll finish the front end on Monday, and we'll see what difference that makes. But I wanted to take it for a lap with the new rear end alignment and see if we were gaining on it. And I'm kind of encouraged by the Soapbox Derby result there. We're not quite as free-rolling with the vehicle as the Speedster is, but we're considerably better than the Spider was with a 3,000-pound vehicle. And we're going to do some mixed city and freeway driving here today, but it's just a lap from the shop up our 22 miles up and back on Interstate 55. I'll do about 50, 55 miles an hour. We'll see how that goes. I'm rolling along at 35 miles an hour here in second gear. We get quite a bit of engine and motor and transmission noise. I think that's because after balancing the pressure plate, clutch, and flywheel, we changed the pressure plate. And we really need to change that back, since it didn't have anything to do with the clutch slipping, because it was actually the positive traction rear end that was slipping. So we have a much better rear end alignment on the vehicle, and I can already tell it's rolling much freer. The steering's a little more stable. The car feels better. Of course, every time I spend a couple $100 on a car, it always feels better when I drive it. So that's what we're about. We also notice our fuel gauge is indicating full. We have that hooked up with the Ziva. Lots of calibration yet to do on it, but I think that's going to work with our Xantrax to give us an indication. Our brakes are firm, they don't fade, they howl, but again, I think it's a matter of seeding in a lot of new, probably not very expensive brake pads. There, she's howling at me. But there it is. Our temperature gauge actually works. We don't even register when we're running, but a lot of times after a run, and we'll see today if this happens, it'll come up after we stop. And that's the heat migrating out of the armature into the rest of the motor where the temperature sensor is. I can push this button in, and now my RPM gauge is going to display current from the Ziva. And I don't know if I have that calibrated correctly yet or not. We'll see if it indicates. Shows a little current, not much. Got cars in front of us, so can't use too much. A little less leverage here on second gear. I'm getting a little more current shown. Let's go to third. Oh yeah, now we're getting up to 300 amps or so. Transmission is loosening up. I'm actually not using the clutch at all since we don't have regen on this. The transmission is doing a very good job of synchronizing with the mass of that 11 HV motor, and I can just move it around. You can't jam it, but if you'll move it, you know, out of one gear and into the next, give it a little pause and just let it drop in. You don't really need to clutch at all to shift with this, and so it's sort of a shifting automatic when you take the clutch out of it. Obviously you don't need the clutch coming up to a stop sign. Gonna get on the highway now and stretch our legs a little bit, gingerly and gently. I'm not real used to this car, and we don't know exactly what we have yet, but we'll see if she'll roll. Yeah, I can just stick it in the notch and hold it there, and it drops in after a second. Third gear, 50 mile an hour, about 200 amps. I'll go to fourth. We're showing 56, 57 mile an hour. 100 amps. Our controller temperatures. I have a C-temp controller. It's at 102 degrees Fahrenheit. My IGBTs are at 98 degrees Fahrenheit, but I'm only doing 110 amps. We're in fourth gear. Trucking down the road at 58. battery amps. We're going up a hill here. That should get me a little temperature, I would think. IGBTs are at 102. C-temp is at 107. I think our cooling system is working superbly. As designed, and probably with a little bit of overkill. That Durali heat exchanger is really quite beyond what's needed for controller heating, but overkill is often appropriate. Up a hill, 60 mile an hour, and we're floating along pretty good. Cresting the hill, I've got 104 degrees IGBT temp. My integrated bipolar transistors at 104. My controller's at 113 degrees. Ryan said he starts to do something at 55C, or maybe it was 137 degrees Fahrenheit. He starts limiting current. Showing 300 motor amps, 200 battery amps, and 100 on the thing. And what that means is that I have got the wrong number of pulses set on the Shiva, either the Shiva or the tachometer. Right now I'm showing right at 100 amps on the speedometer, and I have 229 amps on the motor and 219 amps on the battery. And so what that indicates to me is this is showing me about half of my current right now. And that's a function we have to set on the Ziva, which is the number of pulses per second, or pulses per revolution. And the tachometer, and we have to coordinate that with our magnetic pickup on the front of the motor, so that both our RPM and our current readings are in the right ballpark. So we're showing right at half the amount of current we're actually doing. So we're going down the road at about 200 amperes, and that is battery amperes. And that's a pretty healthy draw at 225 volts. And by the way, I have that figure here. Our battery voltage is 219, 217 at the moment. So we do have a bit of sag from our 230 volts, but not an alarming amount. 200 amperes is about 1C. We shouldn't see a very alarming amount. We'll take this over to Sling Blade put it on the dynamometer, things will get a little bit more frightening. Right now, I'm wanting to test the run on the car a bit, see what we've got going here, make sure no pieces fall off, make sure our controller's operating okay, and at that point we'll take it over Sling Blade Racing in Illinois, put this thing on the dynamometer, and see what George's 11 HV and Ryan's Warp Drive Industrial can do in real time. That'll be fun. Maybe next week. Right now I'm trying to get some range estimations going by driving the car, comparing the actual miles and actual amp hours consumed, and see what we're going to be looking at. But that's kind of glommed up right now with our alignment issues. Front end is still not properly aligned. The rear end now is at least square to the car, and so we're hoping that can be made to come together. I'm doing 59 miles per hour, showing 100 amps, that means 200. Controller temperature is 118 degrees Fahrenheit. Now this is actually something you don't think about. Everyone focuses on acceleration. The hard part for these controllers and motors is not making a lot of power for 10 seconds. The problem is when they have to make a medium amount of power for an hour on the freeway. Temperatures start to climb, and it gets to be kind of hard work because they're not getting a cooling off period. And that's an issue. And that's one of the reasons we do a lot of playing around with overkill cooling. I've got a 434 cubic foot per minute blower into our air-cooled motor, and a Summit Racing style cooling system using billet aluminum fittings, A&8 hose, and a professional racing, really, Durali heat exchanger that's like a small radiator with a fan, and that should keep me fairly cool. Lots of yowling from the brakes. They feel good. I put my foot on it, my hands are off the thing. They're not pulling, they're not fading, and but they sure do yowl at me. And I think we ought to do something about that. Not too sure what. Might just be a wearing in situation. And we pull up here and stop. I'm at 120 controller degrees. I'm starting to register here on my motor because I've taken it out of the airflow, and that'll start to climb until I take off, and at that point it'll go back down. I've used 27.8 amp hours. I have 13.7 miles. Unfortunately, that sounds like 2 amp hours per mile again. So I'm not sure what's going on. Now it is mostly uphill coming this direction, and so conversely somewhat downhill going the other. We'll see what we average out to. My low car pedal, the spring weight is still not heavy enough I get kind of an oscillation when I take off first gear too suddenly, and it's with my foot and the accelerator pedal is what I'm convinced is what does it. I don't think it's the drive line at all. I think it's me. That's because that spring on that accelerator, and it has a double spring. They insisted we return the first one because it was too light. I think the second one's too light too. And they need to put a little horsepower in their accelerator spring. It's a beautiful piece of equipment, the accelerator. Ryan liked it in marrying it into the controller. It has all the proper OEM style sanity check circuitry. And there's that little delay, and it drops into second. We're up and forward here. Go to third. Take off like a herd of turtles. Open along at 200 amps. That was a pretty good acceleration. Let's see if I can read our temperature without dying in the traffic. The sun's working against me. I can't read this. This is not sunlight readable. That's a problem. 116 degree Fahrenheit on the controller. $95 degrees IGBT. We're doing 200 amperes. Kind of up a hill here. Dropper down. We actually have a fifth gear in this car. Not a big current drain. If I go back to RPM, you can see that I'm just not doing anything in fifth gear at 55 miles an hour. Back to current. And now back to RPM. gear. That should be third. Now we can see my RPM. And fourth. We're doing 60 at about 2100. About 190. Now that's 200 amps up this hill. That's 400 amps. If I put it in fifth, that RPM is down around 1200. On this hill, my current's up about 500 amps. Motor temperature is at 140 degrees going down the freeway. So we're up. That's 140 Fahrenheit. We'll start to have a problem with this motor about 300 degrees Fahrenheit. Well, this is actually pretty good. Let's see. If I go down to third, my RPMs go up, my current goes down. Let's see what happens to our temperature. Still about 140. Ooh, that was loud. Hope that wasn't a piece of my car. The temperature isn't moving around much. My current's way down. My RPM's up. 55 mile an hour. Let's go into fourth gear. Now my RPM is 2,000. And I'm up about 380 amperes. Cresting the hill now. And it's rolling pretty freely. I take my foot off the accelerator. We're slowing down to 53. Going down the hill, 51 mile an hour. Give it a little bit, fourth gear. We're at 150 degrees on our motor temperature. I'm reading 95 on my DVTs. 129 degrees on the controller. Motor continues to climb. We're up 152 or so on the temperature. Our cooling system seems to be working pretty well. Coming up on our Interstate 55 exit back onto Highway 74. Back to the shop, but it's not wandering too much. Pretty stable car. Rolling reasonably freely. Dropping down into second gear. They do whiz by out here. Be nice to have a test track instead of being out here with all the traffic testing these cars. You kind of make do with what you've got to work with. But Friday afternoon traffic on the interstate highway system is not an ideal situation to be doing some testing. I have to note off, I'm not doing any current in third gear. $165, I'd say, on the motor. It's getting warm. It's been.
NetGain Controls introduces the new Warp Drive Industrial Controller. The Industrial is designed to handle a maximum of 1400 amps and up to a 360 volt nominal battery pack. The unit's rugged design looks and works great in the automotive environment while protecting it from the elements. In addition to higher continuous currents than the classic Warp Drive controller, the Industrial comes with several major enhancements. Liquid cooling is available and uses leak-free and rugged AN fittings. The Industrial controller has complete isolation on both throttle channels, giving the highest possible immunity from situations that might affect the electrical throttle input. High voltage connections are fully protected underneath the sealed cover. Voltage leaks between vehicle chassis and a battery pack are detected, alerting the user to potential safety problems. Controller settings can be completely customized using the NetGain Controls interface module, which can also log data to an onboard SD card. The controller weighs in at 25 pounds. Visit www.ngcontrols.com to order your Warp Drive Industrial Controller now.
Okay.
There you go. For all of you that were waiting for that.
Yeah, as you can see, I'm testing a lot of things, and this is not a steady state speed 55 or 45 or any of that, 40 like we've done in the past. This is just, and I was kind of,
it looked like you were kind of humping it there a little bit.
Accelerating.
Yeah.
I mean, not
not hardcore
performance run, but you know, and
you're starting to like it.
I am starting to like it. You know what's funny? During the convention, and we thought the clutch was slipping, you guys changed the pressure plate.
Yes, and yeah, we did.
Well, that's all well and good, but this happened with Speedster Redux too, and you got to fix that one as well. We had very carefully sent off the flywheel, clutch, and pressure plate to be spin balanced.
It was all balanced. Yep.
And then you change the pressure plate.
Yep. When the guys put the new one on, it was not
Guess
balanced.
what?
Yep.
It's not balanced now.
Yeah. Yeah.
So this thing's got a buzz in the drivetrain.
Yeah. It's not that.
Now that's the sort of thing I got to tell you, Brain, that really annoys me. Except in this case, I really like it.
What does it give you a little thrill?
It gives you a little V8 there. You know, I mean, the noise is kind of like having the baseball card on your bicycle spoke.
Yeah.
You know, making the noise.
Well, you know what's funny, and this is in the news, in one of my news things today, we'll just talk about it now, that Ford is not going to put the noisemaker, I guess, on their first generation electric Focus. Good. They did find that the sound that people like the most is the sound of a internal combustion engine. So there you go. You just proved that out. A big V8.
Yeah, it kind of, it's got a buzz in it that makes me feel like I'm...
That's why girls like Harleys.
That's right.
Comes up through the seat.
Rattle, 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 rattle.
It's called the joy seat.
That's nasty. The way you think.
I can't help it.
But that shows you kind of what I'm doing on a test drive,
Yeah.
and it was not a controlled situation, but at 2 amp hours, 1.96 amp hours per mile is not encouraging.
No, that's not cutting it.
And so what I've done is offer Paul his money back, and we'll keep the car.
Well, I bet that. I bet he wants the car even more now.
Yeah, so far he just wants the car. But I'm that kind of guy.
So you're starting to like that Cobra.
Do what I tell you, I'll
buy it back.
I'll buy it from Brian and give you your money back, and I'll just keep the car.
Keep the
driving.
car. That's right. We'll drive it.
I never get over it. I love these cars.
They are pretty cool. Gotta love electric cars.
So we're going to keep working on that. We've got to get our tachometer, ampers working right. I've got to calibrate the gas gauge. You need to build us a touch-safe shroud over all that mess I have left onto the hood.
You know what they said? Put it behind something black, it'll disappear.
Paint it black and it disappears. That's right.
Yeah, we'll just spray paint the whole
thing.
We'll
just spray paint the whole thing black. No, make me a neat thing like you do. And then we'll go to Sling Blade next week and find out what it does.
See what it does. Okay.
You can take it out on the road and see if you can do a quarter mile, 0 to 60, and that sort of thing.
Okay.
The speedometer is supposed to do that for you, but you got some sort of device anyway, don't you?
Yeah, we've got. Well, I can do the drag strip in the box, the G-Tech, and the speedometer at the same time.
There you go.
That's what we usually do.
And so we'll know more, but I think we're going to find this car's kind of cool.
Good. Okay. I've just got to get used to that transmission.
I do want to do some range testing, both with these tires and with the original tires. But I'd say another few weeks, we'll be ready to deliver this and move on to other things.
Okay.
And we've got other things to do.
We do.
Let's see, Chevrolet has gotten religion. You know how I have tickled them mercilessly on two things. One, the Volt not being an electric car.
Have you seen the ad about the Volt where they got the gas station and everybody?
Yes, I have.
They've kind of got it.
They've kind of got it.
They kind of got it.
And the Spin Meisters are now backing off.
Okay.
They're actually saying that, it doesn't matter if it doesn't sell very well. It's bringing a lot of people into the showrooms.
To buy cruises?
To buy cruises. And
high profit cars.
It's got us a lot of press, and it's been written up very well. And if it doesn't sell very many, oh well. You know.
Interesting.
And so this haunted me from Who Killed the Electric Car.
Yeah.
The problem with that documentary is it implied that everybody wanted one of these things.
Yeah, which still isn't the case.
Everybody doesn't.
No.
And it is, at this point, a very small market of people that are willing to pay that kind of a premium to have an electric car.
Very low percentage, yeah.
And guys, you can wish we were all, communists if you want, but there's no way to make them inexpensively right now.
Not right now.
Do it.
No.
But Chevy did introduce, and this is an interesting story. I showed the A123 20 amp hour packs, and that I have to buy them from China because A123 won't. A123 had bought $30 million investment in Fisker so they could claim an OEM was
Using their batteries. Yeah.
They were down to under $2 a share on their stock.
Oh, really?
And this week, General Motors announced that they are going to build a fully electric car.
Oh, okay. Yeah, I did see that.
It's called the Spark.
The Spark, yeah.
And Sparky is going to use A123 cells.
So that's where they're going to put the cells. Okay.
The stock doubled to $4. And who knows, maybe someday they'll even sell me some.
Yeah, and that's going to be a real small car. That's a car, I think, in Asia right now.
Well,
isn't
and it's not a bad cell. You can make a pretty nice lightweight pack with those cells.
Yeah.
And I don't think it's going to have extreme range or anything, but they're talking about a 20 kilowatt pack, a much smaller car.
A small car, yeah.
And you know, a real electric car. Kind of Wego looking.
Yeah, it's a little car.
Like a small Fiat 500 type thing, or a Smart.
Right.
You know, it's a micro car, but you know, hey, welcome to the party, General Motors.
Yeah.
That electric car, you can tell because you don't put gasoline in it. And so welcome to the world of electric vehicles. I'm sure you'll find it interesting, if not profitable.
Yeah, and they'll be in the conversion business, just like everybody else.
No, I mean, it's their original design car. They're going to do a gasoline and an electric, but you know, I'm okay with all that.
There you go.
The problem again is the value proposition. It'd be an interesting experiment. And what I would suggest is you offer this car, the gasoline version, and the electric version at the same price.
You just eat it.
If you have to raise the price of the gasoline version a little bit to make it a profitable venture. As an experiment to see where you're at.
Just kind of gauge the consumer.
If this would be an interesting data point if they offered a micro car at the same price, gas or electric. Is it really the range anxiety that is the public perception, or is it just who wants to pay a premium for an electric car? I think it would be a very interesting experiment, relatively inexpensive, on a low volume, bottom of the line micro car.
Yeah, see what they...
And see what you wind up with.
Yeah, I like that idea.
You're almost subsidizing the electric car, but that helps you with all your CAFE standards and so forth, too.
And you're getting some good information, because what is it that people do? Is it range? Is it charging times? Is it price? Take price out of there. And
they have the resource to do it. It's at the right end of the scale to do it.
Right.
And I still think that electric cars, the component costs should be buried at the other end, the early adopters and Tesla style cars. But if you want to do a little bitty micro urban car and an electric car and plant your flag there, why don't you just bring them out both at the same price?
Take price out.
Take the expected sales of the two of them and price it as if it was all one lump.
Right. And see what happens.
And see what happens.
Yeah. Yep. Good idea.
And I think it'd be a fantastic experiment for General Motors and for everybody else in the industry. And at the right end of it to be an affordable experiment.
Right, where you don't get creamed.
Where you don't get creamed.
And that's where they're trying to go, the mass market, see what the mass consumer is really after.
NetGain Motors, home of the Warp, Transwarp, and Impulse motors, introduced the improved Warp 9 motor. The Warp 9 is a 9 1/4 diameter series wound DC motor with a double-ended shaft featuring 26 improvements for 2010. Externally, the terminal studs have been enlarged from 3/8 to 1/2 inch diameter. Bigger is better. On the inside, a larger commutator, new brush composition, and split brush design with heavier springs handle even higher voltages and currents than before. Our new fan increases airflow by almost 50% over typical paddle-style fans. And all this translates into improved performance. For even more performance or larger applications, take a look at NetGain's Warp 11 motor, an 11 3/4 diameter series wound DC motor for even greater torque and power. Since 2002, NetGain Motors has been leading the EV industry with precision, performance, and price. Visit us at go-ev.com. NetGain Motors, warp power to go.
I hate to keep touting Tesla, but they filed an 8K this past week, October 5th,
Okay.
noting a substantial change in their business, which was a financial agreement with Panasonic.
No, that's right. Yes.
Panasonic Sanyo, they bought Sanyo.
Right.
Panasonic's one of the largest battery manufacturers in the world, and Tesla did a financial agreement obligating to purchase and getting a long-term purchasing discount for enough cells to do 80,000 cars.
Oh, okay.
And they're planning on using 8,000 cells per Model S.
Man.
Well, it's 8 times 80. It's like
6.4
6.4
million, yeah.
cells.
Yeah.
I wish I could buy cells with Tesla's group buy.
Exactly.
Because I bet they're not paying as much as I am.
No, I don't think they're paying a buck an amp hour. Huh?
I thought it would be an interesting time, particularly since they make the information so poorly available. Tesla wants you to believe that they really invented the battery.
Oh, okay.
And the car, the whole time they were doing the Lotus Elise, the Tesla Roadster, they insisted that that was really their entire
proprietary design.
Proprietary thing. And it had their proprietary motor and so forth, which they got from AC Propulsion. But it was all Tesla stuff. They have a bad habit of claiming other people's work.
Oh, okay.
You know, and I can't fault them for it because all the automakers really do that. They just
source a lot of
they
stuff.
source everything and assemble it, and the only thing General Motors or Daimler does is stamp the metal.
Right.
You know, so
Put it in on the line, yeah.
it's hard to fault them for it, but it seems disingenuous in this case. They've similarly, this is a custom cell by Panasonic for them. Not exactly.
Okay.
They didn't design the cell, and it's not exclusive to them. Panasonic has got 2 new cells that are kind of cool.
Oh, okay.
And I'm not given to these kind of cells, but I thought we would walk through some numbers to illustrate how Tesla Model S can really get 300 miles per charge.
Okay.
And if you wanted to, you could too.
All right, okay.
Tesla's original concept was that they would get a better price on cells buying from a company that provided millions of cells to flashlight and laptop computer enthusiasts.
Okay, that makes sense.
You know, it's not a bad concept.
Yeah, that makes sense. They're already cranking them out. They've got the
They're already
production
cranking them out.
facilities. Yep.
So what they used was a cell, very much like this. This was 2,200 milliamp hours. But this is called an 18650 form factor. It's about 18 and a half, as it turns out, millimeters in diameter, and about 26 and a half millimeters in length.
Okay.
And that's just a size, a standard size for a lot of devices.
Okay, all right, yeah.
2 or 3 problems with these cells.
Okay.
The first and foremost is there a lithium cobalt oxide cell.
Oh, okay.
Lithium cobalt oxide is probably the least safe cell. This is where the laptop and cell phone fires came from.
Yeah.
And the reason for that, they have a little bit higher energy density, but than the lithium manganese, or certainly than our lithium iron phosphate cells. But lithium cobalt oxide, or any metal oxide lithium battery, at some temperature will give off oxygen from the oxide, and that self-fuels a fire.
Yeah, like a sparkler.
Right. And so if you get in a short situation or a puncture situation, as the temperature goes up, it starts to feed itself oxygen, and it makes a very intense, at times explosive fire. This is unacceptable in a vehicle, as far as I'm concerned. Panasonic has taken this on and done some interesting things to ameliorate that. But in the case of the Tesla battery pack and this Tesla purchase, they are coming out with 2 new cells. One of them will be produced in massive quantities in a massive run in March of 2012.
Okay.
And the other one is going to go in March of 2013.
Okay.
The other issue I've had with the cells is making modules for all these little cells is a lot of connections and hard to do.
Right.
I like the big prismatic cells. I like the safer lithium iron phosphate cells.
Right.
So we don't run these, but we might want to take another look.
Okay.
And that's simply on the energy density. The new cell is again, it's a cobalt oxide, but they're calling it their nickel new platform NMP cell.
Okay.
And it's really a little bit more advanced cathode material. It's lithium nickel cobalt aluminum oxide cathode. LiNiCoAlO2.
Okay. Must be good.
Yeah, must be good.
Must be good.
It's longer. It is the 18650 form factor.
Okay.
The cell will deliver 3.4 amp hours in an 18650, which is a huge amount of power.
That's amazing. Yeah.
These cells, and note that all cells, when we talk about voltages, charge curves, and so forth, we're talking about our buddy, the lithium iron phosphate cell. I cannot get this across to people. They say, oh, my buddy has used lithium polymer cells on helicopters, and you got to do this, or you got to do that.
Right.
I don't know what you got to do.
Yeah, we don't know anything about those.
Never tested one of the cells in my life. It's lithium polymer and lithium cobalt oxide cells have the same relationship to a lithium iron phosphate cell that a lithium iron phosphate cell has to a nickel metal hydride cell or lead oxide cell. They're different chemistries. So the voltage on the lithium and nickel cobalt aluminum oxide cell happens to be the same as a lithium cobalt cell, 3.6 volts. Now when you get done charging and it falls back down, it's going to breed 3.55 or 3.57, something just short of 3.6 volts. The other problem I've had with these cells, and I called it Tesla's dirty little secret, and that was the 300 cycle life.
Yeah, that's not a lot of cycles.
You know, it's not exactly what I thought either. It was true, and I wasn't wrong.
Okay.
Dan Friedrichsen, it's true, and I was not wrong. This guy sends me an email every day of what I've done wrong. He's like 24. He's never been in an electric car, but he's...
Didn't he take a ride one the other day?
Yeah, I think he did get his first ride in an electric car. I'm not sure he's not 14. It's starting to sound more like this all the time. The other issue is cycle life. These get 2,000 to 80% depth discharge, 70%. Now let's do another 80, 70%. The 300 cycles, in this case on these new lithium NNP cells, nickel, cobalt, aluminum oxide cells. Let's call them NNP for short.
Okay.
I wanted you to know what they really were because the Panasonic's a little shy.
I don't want to say what the chemistry
is. Their
is.
Proprietary cathode thing, which is like the Tesla secret custom battery, and so they call it NNP, but it is really lithium, nickel, cobalt, aluminum oxide is the cathode material, period, and no magic sauce in there beyond that. But they call them the NNP. They'll do about, it looks to me, to about 600, 500 or 600 cycles on their graph. But this is an industry standard. What has emerged is you state the cycle life to 80% of the original capacity.
Yeah.
And they're kind of stuck with that.
Okay.
And so these new cells will do about 500-600 cycles to 80% capacity.
Okay.
That's the bad news. The good news is they'll do well over 2,000 cycles to 70% of capacity.
Really? Mm-hmm. That's an incredible difference for that 10%.
It is. What
curve.
it is they have a life decrease. It's kind of sharp in the first 500 or 600 cycles, and then it levels off, and these things are good to go for a long time.
Oh, okay.
If you can live with 70% of the original capacity. So
guess
that period from 80 to 70, it's just kind of, and it could have been anything. This could be to 40% capacity. This is a made-up standard.
Right.
It's not even a standard. There's no standards body. It's a convention when stating the lifetime of a battery to state it. It used to be 20 amp hour rate.
Oh, yeah.
Now everybody
right.
does a 1C rate. The cycle life is by convention.
Mm-hmm. Yeah, right. No one's out there putting the
It's just
rule
a
out.
tradition.
Right, yeah.
Stating it to 80%, and Panasonic kind of loses the game there. 500,
Right.
600 cycles.
Right. But then they get so much better.
They can beat a lot of the other batteries out there if you go to 70%.
If you go to the other.
Because it flattens out pretty nicely, and it really doesn't end at, you're really not quite to 70% at 2,000 cycles.
Okay, wow.
And so they do not have as short a life as I implied. And conceivably, the earlier CGR cells are the same way. I didn't have a lot of information to go from. I've got a graph for these.
Okay.
And so the bad news is 80% capacity, short life, 500-600, still better than 300.
Yeah.
Twice as long. Secondly is the if you can live with 70% of your original range, 2,000 cycles, very good life. And so that's the nature of these cells, and so you have to use that in a trade-off. The safety issue, somewhat ameliorated by the nickel and by the aluminum.
Okay.
But they've done a couple of things inside the cell. And the first is right under the button here is a disc of positive temperature coefficient material.
Okay. Okay.
And so if you're using this cell at its normal rate, and one of the drawbacks is these are kind of 1C cells. They don't do any 20C power output.
Okay.
They're all about density and long life, not about long life like will power your flashlight longer,
right,
because of their energy density. So these are energy density type cells. They don't put out a tremendous amount of power. But if you do draw more current out of this, this PTC disc, they sometimes refer to it as a current limiter. But if you shorted the cell or something, it's going to go up in resistance and decrease the amount of current the cell will deliver. And that's a very good safety feature.
Yeah, excellent.
Between the separator and the anode, they have a metal oxide layer that is called the heat resistant layer that kind of shuts down this cell if it gets punctured or shorted or something like that.
Okay, okay.
It's almost like a fuse.
Almost like a fuse, yeah, that's how it sounds, yeah. Okay.
And so that's the, this is some of the stuff that Tesla alludes to as if it's in their battery management system. It's not.
It's in the heart of the battery.
It's in the cell.
Yeah.
And so that's kind of a neat safety feature. And so these cells are probably at an acceptable safety level for a car.
Yeah.
Or could be made into a module that would be.
Absolutely.
And so that's a notable thing. But by far the news is the power density. I mean the energy density.
Yeah.
At 3.4 amp hours and 3.6 volts, that's 12.24 watt hours
Okay.
in this battery.
In that battery, yeah.
And the battery weighs 46 grams.
Jeez.
And so your watt hour per kilogram on this is 266.
Oh, man.
And that works out to about 120 watt hours per pound.
Okay. Okay.
Now, our lithium iron phosphate cells, maybe 106, 109
Right.
watt hours per kilogram.
Kilogram.
And that's, what is that, 45 or
yeah.
something?
Yeah, 45, 50 a pound.
48.89 watt hours per pound.
Yeah. Whew.
And so
Man,
this
those
is
are big boys.
almost 2.5 times the energy per weight.
For the weight, yeah.
And that's the trick.
Wow.
Now let's talk a little bit about what that really means. In a real world situation, we built Speedster Duh. I've driven that car 110 miles
Yep.
in a drive, not a theory, not a calculation, without damaging the cells.
Yeah, right.
Of 36 of these China Aviation Lithium Battery Company 180 amp hour
180
cells.
amp hour cells,
They
yeah.
used to be called Sky Energy. That's 21,708 watt hours, and that's right at 200 watt hours per mile. And that's on a drive to Perryville and back and through town. It's not a flat surface, no acceleration, 45 mile an hour deal.
Yeah,
That's a real driving.
Yeah, it's not a straight range course or something. Yeah,
So,
that's
so
real
it
world.
sort of averages
Right.
200 watt hours per mile.
Yeah.
And I'm very pleased with that, by the way.
Yeah.
And that gives us a range of about 110 max, which is why I can say 80.
Yeah, 80 to 90
you know.
safe, sure.
Sure.
Yep.
And so that's where we're at. That pack weighs, I've got it here somewhere, 444 pounds.
Okay, yeah.
We have 444 pounds of batteries in a car that weighs 2,025 pounds. Now, if I did that same 21,708 and had that same range using these NNP March 2012 3.4 amp hour cells, my battery pack would be 180
Oh,
pounds.
man.
We would pull 264 pounds off that car, and Speedster Duh be 1771, 35 pounds lighter than a Spider.
Oh, man.
And it would absolutely dance.
Yeah, yeah.
This would be a cool car.
Yeah, with 300 pounds out of
performance-wise.
that? Oh, man.
If we went the other way and put 444 pounds of these
Those
in it,
there. Okay, kept it the same weight. Okay, battery weight.
that would be 4,380, by the way, of these cells.
Okay, okay.
And at 3.6 volts and 3.4 amp hours, that comes out to a pack size of 53,611 watt hours.
Oh, man.
And at the same 200 watt hours per mile, that's 268 mile max
Oh,
range.
man.
Probably 240 safe,
Yeah, 240 say, holy moly.
which is what the Roadster is.
Which is right, right. Oh, man.
And so that's how we could easily, at some expense, and packing 4,380 of these into, and they're not individually wired. They make copper plates.
Yeah, right, and lay them
And
on,
they
yeah.
put them on it and take another plate and in a box and spring load this where they're together and do some temperature monitoring and that sort of thing. And they're not, you're not hand wiring,
No, geez.
4,380 of these. Tesla doesn't do that. You could do modules out of this, and you could make a Speedster Duh do 268 miles
Man.
with these batteries. And that's pretty cool. You wouldn't get the cycle life you will with these. You have the additional weight in there somewhere. You're really not going to get 268, but you could get a 200-mile car if you replace some of the 448 pounds with the plastic and terminals
Right.
that you need to modularize
To make that, yeah, make modules,
these
yeah.
cells. But you could easily have a car that did over 200 miles. You can.
Yeah, and you can put batteries in all kinds of contours.
Well, that is
and
the
things.
neat thing. You can make the modules form fit the
Yeah,
car
right.
a lot
Yeah,
better.
which we're always working with
You
rectangles
probably
and
would be
squares.
back up to 250 miles.
Yeah, because you could really put them in the nooks and crannies.
The next year, they're going to do the same cell at 4 amp hours.
Oh, man.
And how they're going to do this is they're going to replace the carbon anode with a silicon alloy. We've been talking about
Right.
silicon anode cells. They're going to do it. They've
Okay.
already got it worked out.
Wow.
And they're going to replace the carbon anode with a silicon alloy. Here's the problem. The cell weight goes up to 54 grams, and you wind up with exactly
From
this.
46?
Yeah, from 46.
Okay.
You wind up with exactly the same density per kilogram of power.
Okay.
But your volumetrics get better.
Yeah.
The cell doesn't get any bigger. It's still 18 by
For
65.
4 amp, yeah, for 4 amp hours? Mm-hmm. Oh, man.
So that
Jeez.
lets you get more watt hours per volumetric space.
Right. Yeah. A little extra weight.
Yeah.
Yeah.
10 and a half pounds in a 10-pound sack of potatoes.
Right.
Right.
It's
It's
getting
still
better.
going to weigh 10 and a half pounds.
Right.
But you could get it in a 10-pound sack
Right.
by volume. And that run is going to be March of 2013. Again, Tesla has subscribed for enough of the cells for 80,000 cars,
80,000 cars.
through 2015, which very closely matches their estimated production of 20,000 cars per year.
Per year.
Over 4 years.
Yeah.
And 2015, if this car does well in 2012 and 2013, I think there's a problem there. I think
Not enough batteries.
I think Panasonic's going to have to. But, you know, they have time to adjust
Right,
this
right.
as they go. That's the contractual obligation now. And everybody, I'm still fielding them from people that are predicting the demise of Tesla. There's still a stock sold short. I'm telling you, these guys are executing.
Yeah, they are. Yeah, they're executing.
They're just hitting on all cylinders,
hit-
and they don't have any.
No, they don't have any cylinders.
Well,
That's
they
right.
have about 8,000 little cylinders
Yeah.
to hit on.
They're cylindrical.
They're
Yes,
cylindrical.
they're cylindrical.
So I wanted to kind of go over this
That's great
battery
info.
thing
Yeah.
and kind of show you how, why, when Tesla can do a 300-mile range car in a sedan size.
Yeah, they can do it.
And they've done a pack that's all flat on the bottom, lowers the center of gravity. I'm telling you, this is going to be a gorgeous car. It's just going to be an amazing thing. We're probably going to stick with these for a while.
I think they're good for conversions, and especially at this point too. I mean, people understand that battery. You can work with it.
They're safe.
Yeah.
They're
Yeah, they don't need to have temperature regulation.
they're easy for me to work with, and I just don't need 200-mile range.
No, not right now.
I mean, I
These
just
will
don't
get better,
need it,
too.
Brian.
Yeah.
It's not. It's where I live. It's who I am. Your mileage may vary. A lot of people would want more range.
More range, yeah.
If I had more range, it's kind of like Redux. It goes 150 miles. I don't go 150 miles.
Right.
So it's sort of meaningless to me. We're past this threshold of viability for moi because I don't need
don't
to go
drive
that
that
far. Are electric cars for you, and you have longer range requirements. It's not that far out in the future.
No, it really
March
isn't.
2012 is when this run's going, and March 2013 the next. I assume Panasonic would probably actually sell us cells for money. I don't know that. I haven't tried, but they sell them. These are
they
appear on eBay and
Yeah,
stuff. I mean,
yeah.
there's they're often rebranded and stuff. But you know, Panasonic bought Sanyo. It's one of the largest battery manufacturers in the world. I would say in about a year, you're going to start seeing 3.4 amp hour cells on the market.
Yeah, they'll start percolating up, yeah.
But they tend to be $10 a piece, you know,
Yeah, that's
on
right.
eBay.
Yeah.
People are buying them for flashlights. And so maybe if you bought 4,000 of them, or like I say, I could have done the same pack size and kept the same range and taken off a huge 10% of the weight of the car, more than that.
Well, and that's more range.
With 1,774 of them, I see these kind of cells online for $10. That's $17,000. That's a little pricey.
It's a lot. Yeah,
you'd have to, but if you're buying 1,774 of them, I got to believe
they shouldn't be.
I don't know what the
piece.
price. This is for 2 of them.
Yeah,
so
right.
For your flashlight,
right.
Is what they're selling on eBay. So, I don't know what the price of these cells are, or what they'll be. But if they're in the ballpark, and I would say Tesla, in committing to 80,000 times 8,000.
Yeah, 6.5
million. No, that's 640 million cells.
Yeah, that's
a
lot of them
almost a billion cells.
Yeah, that's a lot of them floating around out there.
Cells.
Yeah.
That's a lot. They're probably getting them for $1,
Yeah.
And at that point, they've got an $8,000 pack. That'll take them 300 miles.
That's amazing.
See, all this starts to work.
It starts to work now.
And
yeah.
I've been talking about economies of scale and things. It just
yeah, you need to be making that amount to get the price down. Yeah.
I mean, that's
the way it is.
That's how it works, guys. I didn't. This isn't my opinion. I didn't set any of these rules. It's just.
Yeah, that's the way of the world.
It is, and it's all part of an ordered universe.
That's right.
Ticking like a clock on its merry way. You can't do it different. What else do we have to talk about?
Well, we talked about the Ford Focus. We kind of talked about this. I mean, Deloitte & Touche has done some things. We talked about range. We talked about with the Spark. They need to find out what people are really after.
Yeah, I think.
Is it price? What is it? No one knows.
Very little information about the Spark or any specifications.
All it says is that they're going to do a gas-powered one next year for the United States and other markets, and it's sold right now in China, India, and South Korea. And it's a mini car, and that's really what we know about it.
Chevrolet rolling out the gasoline and the electric at the same time and at the same price. Let's see what you got.
See what they got. Yep. See what they got.
Bring your A game, man.
That's it.
Why?
Yeah. Let's eliminate some of the variables.
Why show up striving for number 2?
All right. Just go for it.
Let's bring your A game and let's see what you got.
Yep.
And I'd drive one.
Yeah.
If they're at the right price.
Exactly.
And that's the trick. We'll tack on. I'm finding some more Christopher Fisher video of our convention.
Okay, good.
I'll stick something on the end of this one.
Stuff's bubbling up, yeah.
For now, and for EVTV, I'm Jack Rickard.
And I'm Brian Noto.
We'll talk to you all later next week.
See you then.
Stay with us on this Cobra thing. I think we're going to
I think we're getting there.
I would be remiss in telling you all week to thank Jeff and Blaine Brown. And I would like to propose a toast to you. The truth is, I find trade shows and conventions an extraordinarily stressful form of business, and Brian just loves them. And so, in bringing this first electric vehicle conversion convention, I have to admit at this point that I was almost a very good idea. That the deal was, Brian, you can do it. I'll give you a couple of people to help, and you stay out of my freaking hair. And don't mess it up. And actually, he has, in my opinion,
superb pursuit. Out of my hair, but I pulled him off his project to help me with the Cobra about 6 days out of the last 2 weeks, which is a cruelly unfair thing to do. And he never made a peep. Got right over the car and got right with it. And so I'd like to propose a toast to my compadre and consigliere. Here, here!
Nice job,
We do have a series of awards, and he's the only one who knows actually who won and so forth. I'm going to ask him to come up and get this started so we can complete it sometime prior to the departure for the winery at 10 a.m. Would you all please give a warm welcome to
Well, thank you, Jack, but I always told you so. All right, so we've got a few trophies here, and the moral of the story is we have always told you to build really cool, really sexy, really hot election cars that people want, and they won. They pretty much won. This was not my opinion. This was the track, the timer, and the River City Rodders, who have some pretty nice street rods around here. So I'm going to go ahead and run through this quickly. Let's do the autocross awards first. The most improved time from a 75.904 to 47.521 goes to Charlie Rickman in his 73 Opel GT. So that was pretty impressive. So if any of you have seen the BBC version of Top Gear, there's a little guy that runs around in a white helmet and a suit and everything called Stig. And Stig does a lot of interesting things. So we have a Stig Award. And our Stig for the show did a 360 with his hands up. And that is Christopher Fisher. Third place in the autocross with a 42.457 lap. And a Chuck Peck 904 was Dwayne Ball. Second in the autocross with a 41.879 and a 78.911 was Sebastian Bourgeois. And first place with a 40.542 in a Tesla was David Ridley. And I'm telling you guys, the good cars are winning. So, let me give you a third place in the car show. And this was judged by our local guys, River City Rodders. They have some very nice cars. There are people around here, some Mustang guys, some Chevy guys that send cars around the world. I had no idea they were here. And they use some very interesting and very high-level cars. Third place from Lubbock, Texas, Charlie and Cameron Rickman. We have an award for the best paint, and it's brown. And I don't know how a brown car ever wins best paint, except from a technical standpoint. Again, Sebastian Bourgeois. Second place for the car show to Dwayne Ball. Best technical, there is one thing about spending millions of dollars on engineering, and only Tesla can do it. And I hate to give an award to a manufacturer, but it's not an OEM. It's a very tight manufacturer that we feel, as Eric Chris taught us, that it was they're really a technical company and a financial company. They don't build cars. With his Tesla, David Ritter for best technical car. And first place in the car show, Sebastian Bourgeois. So we do have a Texas show. He has not won a trophy here at all. This is his first and only trophy. Best of show with a Porsche 356A 1957 Spider goes to Eric Chris. I do have two special awards, and these are from me. And every show has a couple of SOBs. And without SOBs, you really can't have a successful show. And what I'm saying is these are special people who put out and do a lot of things you wouldn't expect. And in fact, there were people who showed up here Sunday night for the show, and I really can't believe you guys need something else to do. But we needed wireless internet, and Mark Weisheimer is the one. He gets the SOB award. He saved our butt. Now, our second SOB goes to the man who made the drag race really happen. The boxes showed up last Friday. And the only person who's going to do that, Jack talked to me and said, I can do it and you don't have the time to make the drag race happen. There's one person that made this drag race happen, and it's Alfred Gajda. You are an SOB. Thank you. Jack, let's move this thing right along to the boring things. Have some more meat, more wine, also.
The drag race. Results on that. All right. We probably have one more SOB, but it happened so recently, like probably 20, 25 minutes before dinner, that I'm not too sure how to do it, and I'm not even sure who was involved. Who looked under the car and saw the shaft on the Cobra turning, which means the clutch can't be slipping, and the wheels not turning. Can you rise and give me your name? George Hiller. George Hiller. Jerry Anderson actually got the thing going down the road. And so we have SOBs that are so fresh, they're still sort of pink around the SOB part. We did have a drag race. The fastest street legal car was again David and Ribnack with the Tesla. David, what was your time, you recall? 13:1. 13:1. This year, we actually did announce a thing called the EV Cup, and we put up a $2,500 purse for the fastest car. Is Ron Demelich with us? What was the time? 9:25. Then you get to come up here. I'm sure there's a trophy involved somewhere, kind of a cheesy plastic looking thing. Speaking to you in my most sincerest form, which is decimal, may I present a check from Electric Vehicle Television in the amount of $2,500. Was somewhat instrumental in doing this. I have to tell you, in fact, I'm going to ask him to talk to you about this a little bit. I don't really understand the racing thing, and the Excedra, the Nedra, and the Excedrin, and the Tylenol. But I understand that there have been some developments in electric drag racing that we can't announce now. And so we won't, but they're going to be really cool things. But Ron is establishing the East Coast Series, which puts me in a particularly awkward position. We're technically on the East Coast of the Western United States, which is how we view the Mississippi River. So I'm not even sure where we're at on this. Very briefly, what you're going to do with the East Coast Series and where you see electric drag racing going in the next 2 to 3 years. What's going to happen?
The way I look at it is we have to have a series, not just associations, because the NHRA and the IHRA are going to build classes for electric drag racing. It's going to happen. It's going to happen soon. If we're able to build series and work with the NHRA and IHRA and not fight against them, we'll get a lot farther in drag racing with electric vehicles. And we'll be side by side having our own events under the banner of NHRA. And I feel that's the way to go. And I want to thank you, Matt, for putting on this wonderful event, and Brian, everybody else that volunteered and helped me with the race, and everybody that participated in drag racing, because I know it was the first time for a lot of you, and you guys did an excellent job. Wonderful job. Thank you, Matt.
All right.
Thank you.
Woo!
Again, I tend to know just a little bit more about these things than I quite understand. And but he was telling me that apparently we were the largest East Coast event this year by number of participating cars of 2011.
You were the largest drag race this year, West or East Coast.
The largest drag race. Because I saw a couple of young Hauber go through several times. I'm not sure. On the other hand, it was kind of interesting to see my 76-year-old mother come down the road. Probably minor ones, not happy.
Not only going down, but had an EV grid coming back.
She did have the EV grid, though. So that's pretty much it. I guess I should go through a little bit about our contest, which, excuse me.
You guys don't see this in the video.
Edit this part out.